So have you been able to attempt the mock? Yesterday
Yes,
there
sir.
was mock.
Yes, sir.
Yes, sir.
Okay. How was that?
Yes, sir.
Sir,
I mean, the
not as good.
questions were easy.
Yes, sir. So I'm just having for me, I just have the doubt on that. How to identify whether that's a vector space or not. That subspace part, that is a big problem for me.
Okay. Okay. Who is this talking?
Ritesh Kumar Das.
Okay. Okay.
Sir,
Yeah, we will discuss that.
so one more doubt, sir.
Yeah.
The mock, if we didn't attempt it at the time when it was
Huh.
live, like schedule,
Yeah.
can we do it later on?
Yeah, I mean, question is still open. You can attempt it, and I think solution is also been uploaded, so you
Okay.
can
Oh,
check that one also.
it's under which link, sir?
Which link means in portal?
Yeah, yes, sir. In portal, how to?
So there is a section called mock test and quizzes.
Okay, okay.
Yeah, you can check there.
Sir,
Okay.
can I
Yeah.
ask a question?
Yeah. Go ahead.
Sir, question number 5 in the mock test.
Mm-hmm.
Sir, the dimension of the span shouldn't it be 2?
Okay.
It's given 3.
Let me share the screen. Okay.
Yeah.
This is
Sir,
the question of mock.
fifth.
This one.
Sir, the span should be 2 because this vector 201, it can be written as a combination of the other two. So dimension is the linearly independent ones, right? If I'm
Yeah. Right. Right.
So it should be 2 or 3. I think it should be 2.
The third one is a linear combination of the first and second. Why the third one is the linear combination of first
So
and
if
second?
we add these two, it will come 201.
Is it
Yes,
No,
sir.
it is 101.
101? No?
Oh, okay. I'm sorry.
And
Oh, my
so
bad.
these three are
Sorry.
linearly independent.
Yeah. Okay.
Yes, sir.
Yeah,
So
the
in this
determinant is
question,
not
the
0.
option 2 was particularly interesting. I got it wrong, but it was very interesting because it is covering the entire subspace. It is not a proper
Yeah,
subspace.
right.
Yeah, so I got it wrong, but it was interesting.
Yeah.
Excuse me, sir. What is the difference between proper subspace and a normal subspace?
Proper subspace means the subspace which is entirely contained in the vector space. I mean, the vector space itself is a subspace of the vector space, but the proper is it is totally contained in that. So
Like the way for
let me-
proper subset and normal
Yeah,
subset, like
exactly.
that.
Yeah, exactly.
So any vector space is a subspace of this sphere.
So why
But-
this option 2 is wrong, sir? Why option 2 is wrong, sir? Can you explain? I just joined, sir, actually.
Let me see. Because it will be entirely R3.
Yes.
Span of S will be entire R3. So it is not proper. It is a subspace, but it is not proper. So
If the span of S wasn't the entire R3, then it would be a proper subspace.
then it will be a proper subspace.
Yes.
Yeah, right. So it was, I think, what was that? 1 minus 1 0. Zero, 1, 1 and 2, 0, 1. So first you check the linear independence. So you will get S is linearly independent, right? And so dimension of span of S will be 3, correct?
Yes, sir.
Now, anyway, span of S is subspace of R3, you know, it may not be proper, but it is a subspace. The dimension are same. So from here you can conclude that span of S is exactly R3. So it is not proper. Okay. If it is proper, then dimension should be less, strictly less. If W and V are vector spaces where W is a subspace of V, then W is proper if and only dimension of W is strictly less than dimension of V. Okay, and if dimension of W is same as dimension of V, then W should be exactly V. Okay.
So in this case, we can also be R, real number set. R3,
So real number set is obviously a vector space, right?
So in
Over
so in
R.
that
So it's yeah.
so there is a doubt then, because if there is a set, say 1 0 0 0 1 0 and 0 0 1, then it's a proper subset. Now I mean, how can it be like this in this case? What you said that
What is your example?
1 0 0 0 1 0 and 0 0 1. So if that is W and V is say R3.
No, W means it span of this is W, right?
Right.
This is just a set. So
Right.
span of this is W. So this is a vector space, right?
Yeah.
And what is its dimension?
R3. V is
Dimension.
R3.
Dimension is 3, right?
3. Yeah. Yeah.
So my claim is this is exactly R3.
Yeah.
It is R3, no? Span of this is R3.
No, but it is also subspace. I mean, W is proper subset of V, no?
No, why it is proper? It is exactly R3.
The spanning set will be
First of
exactly
all, you can
R3.
write W as a subspace of R3. Now you see the dimension of both are same. So you can conclude W equal to R3. That's what I have
I
claimed.
understood now. So if
Now-
the dimension is equal, it is exactly same. Or
Yeah.
otherwise, if it's a subset, then it should be strictly less. Okay, got it.
Strictly
Thanks.
less.
Yeah.
So anyway, you can check. You can take any vector from R3, any arbitrary vector that will look like this, right? Now you can write it as a linear combination of these three.
Right.
Correct?
Yeah.
So that's why it is same.
So I have a doubt here. Sunil.
Yeah.
So the cardinality of a spanning set is same as the dimension of vector space, is it?
Not spanning set. So here what I am doing, if I am taking some vector, suppose v1, v2, v3, if I am taking this set and I am taking span of this set, then if this v1, v2, v3 are linearly independent, then dimension of this span of v1, v2, v3 is 3.
Okay. So span of a linearly independent set. The
Yeah,
dimension,
it's same as the cardinality, right?
okay, dimension of the span of linearly independent set.
Because that forms a maximal linear independent set. So that forms a basis of the subspace which is spanned by these three vectors.
No, I didn't get
So
it.
what I mean is,
One second.
It
Can
is
I
the
finish?
cardinality.
One minute. So when one asking the question, I request all of others to just
So,
be mute, okay?
So when we put it as span v1, v2, v3,
Hmm.
so the v1, v2, v3 are linearly independent.
Hmm.
So span of span of this is obviously the vector space.
So let me recall it, okay?
But I'm talking about the cardinality of the linearly independent set given. Like we can't reduce that straight away, right? Like cardinality.
Exactly. So this is the maximal linear independent set, correct?
Yes, yeah.
So it forms a basis, right?
Yes.
So the cardinality of the basis is the dimension. That's why it is 3.
Cardinality of the basis is the dimension of the vector space, but not the cardinality of a spanning set.
No, may not be. Cardinality of the minimal spanning set is the dimension.
Okay, then thank you.
Yeah.
I have a
That's why
question.
you have to check the linear independence.
Okay.
Sir, can I have a question, sir?
Yeah, go ahead.
So if V1, V2, V3 and V4 existed and it was a linearly dependent set, then to find the dimension, when we test for the test of linear independence, how do we make sure that we can eliminate one of the vectors for the dimension to be less than the cardinality of the actual set?
So you have to find the maximal linear independence set in that case. Okay. So you take all these 4 vector, write it in column or row, do the row echelon form.
Sir,
Reduce.
sorry to interrupt. Could you please mute everyone? There's some sound.
Yes, sir. Some sounds are in the background.
Okay. I think everyone is already muted.
No, so there is some kind of
Like some construction sound.
So it may come from
Someone's
my
snoring.
side only. Okay. Yeah. So basically, if you write this as a column
Sir, Vipul
and
is
do
not
the
audible.
reduce low echelon form, and you that's I mean the number of non-zero rows after reduction will give you the linear independence, right?
So we
Sir,
have to
without
do the
complicating
sorry,
things,
sir.
can we say
We have
dimension
to
of
do
span?
sorry, sir. We have to do the matrix form and then test for reduced low echelon.
Right.
It is not sufficient to just quickly. Of course, we can do an initial test quickly with determinants, and then we can.
But always you may not find determinant, right?
Right.
Suppose you are taking 4 vectors from R3. So R3 vectors are, if you write it in row, then it is 1 cross 3.
Correct.
So the matrix will be of 4 cross 3. So you cannot find the determinant, right? If it is not square vector.
Right.
That's why row reduction is important.
Sir, dimension of span of S can be written as dimension of S only, no?
What is dimension of S?
Like span of the vector set, maybe. Here you can see
The dimension of set does not make any sense, right?
Yeah. Dimension of span of V1, V2, V3. Can we say dimension of V1, V2, V3?
No, that's why I am saying dimension of a set does not make any sense.
Yeah, it must be a vector space.
It must be a vector space, na? When it is a vector space, then you can talk about the dimension.
Okay, yeah, got it.
Yeah.
Sir, in mock test question number 2, I just want to clarify something.
Let me open. Yeah, this one.
No, sir. This one.
This is question number 2.
Yes. So the first one, so what I've done is that I've taken 7i to the right hand side, and I've taken a out from that, from the left hand side, and I've taken the determinant.
Yeah.
So it is that. So is that the procedure?
Yeah, exactly. That is the one.
Okay. So second,
Sir, can you explain the first option?
Okay.
So third one also, sir.
I'll explain this one. Okay. I'll explain this whole question. Okay. So a cube plus 3a square minus 2a minus 7i equal to 0. So let me write it. Cube plus 3a square minus 3a minus 2a minus 7i. So I can write it as this. Then I can take a common from this side, left side. So it will give me this. So it is 7i. Okay. Now if I take dimension on both sides, what I will get? So this is some matrix A, this is some matrix B. Right. So determinant, sorry, not dimension. So determinant A into determinant of this.
2A, sir. 2A, I guess, not 2I.
Sir, why
If you take A common, then it will be 2i, right? So determinant of 7i.
7.
Now, yeah. Any doubt till this step?
Yes, sir.
What is the doubt?
Sir, you have taken A common and you have written there I. Is it the same? I mean, 2. We can write this 2i.
What what is A into 2i?
2A.
2a, right?
2a.
That's what I have done here.
Okay.
So,
Yeah.
So why are we taking the determinants?
I will explain why you are taking the determinant. So if you take the determinant, so basically if you want to show A is invertible, what you have to show? The determinant is non-zero, right?
Yes, sir.
Yes, sir.
Okay. So can I show it from here? So what is determinant of 7i?
7.
If I is a n cross n matrix.
7 raised to n.
7 raised to n?
Q.
So anyway, it is non-zero, right?
Yes.
So product of these two number is non-zero. So can anyone be zero?
No.
No.
No. So can we conclude from here the determinant A is non-zero?
Yes.
sir.
Yes.
So which implies that A is invertible.
So
Someone
7.
snoring in the mic.
Yes, sir.
actually.
Yes, sir.
Yes, sir.
I think
Someone is snoring, I think.
I think it's being delivered deliberately. I guess so. That's
Who
my
is that?
thinking. It's someone, sir. We
So
have to.
let me mute all.
I think he's.
Yeah. Is it okay?
See, it's happening repeatedly, sir. So I think
Yes,
we'll
sir.
have
It's
to find
better.
out.
Now it's okay, sir.
Yeah.
Sir, sir, here determinant 7i is actually 7, right? 7 power n. I don't
No,
get it.
is it?
No, 7.
No, 7 power.
So suppose I have a 2 cross 2 matrix, okay? This is 7i, right? When I is 2 cross 2 matrix. What is the determinant?
49.
49.
49,
Basically,
yeah.
the number of 7 at the diagonal. Right? So for n cross n, it is 7 power n. Correct?
Determinant 7i, 7 times determinant I. We can look at that also, right?
No, only the
No, determinant of
is
n.
multiplied by row, sir. Only for one square
So
per row.
if I write 1 minute, if I write this one, determinant of n into a, and a is some say 3 cross 3 matrix, what can I write from here?
N cube.
Determinant of a, right?
Determinant of it.
Okay,
That's what I am.
n multiplies all the elements.
Right.
Okay.
That is the square multiplication, no? Clear, no?
Yes,
Yes, sir. Yes, sir. Yes, sir. Thank you.
Okay, great. So this first problem is okay, I think. Anyone has doubt in this problem?
No, sir.
Sir, in option 3, can you please explain the option 3?
Second one is clear. I will explain 3. Second one is clear to everyone.
Second one, I have done it, but I think that this point will be true when AB equals to BA. Am I right, sir?
AB equal to BA for all A and B.
Yes, sir, because I was getting A equals to A transpose and B equals to B transpose. Then if I do AB, then there is A transpose into B transpose. Which is not equals to B transpose into A transpose.
Yeah, exactly. That is that.
So it is.
So to show
true
this,
when AB
basically, yeah, you can produce a counter example for this example. Okay.
Okay, so I followed the hint actually. It was given there.
Okay.
So that's it.
Yeah. So the third one. So let A and B be two matrices. Okay. So for third one, the important point is basically, suppose I have two matrices A and B such that AB equal to identity. Can I say that BA is also identity?
Yes.
Why?
Possible, sir.
It is
because
can I say that?
No, sir. Because there is many cases.
So let me do this. Okay.
So B is A inverse.
Sir. No, sir.
Why? From this, we cannot conclude B is the inverse, right?
No. Only if the determinant is not zero.
Okay, no, we cannot. Okay.
So here it is given that A and B are square matrices. Okay.
Fail at the dimension level only, right, sir? This can fail in the dimension level only. Probably a 3 into 4 matrix and B is a 4
but here it is given that A and B are
square.
Two matrices such that this happen. And I is identity matrix of order n. Okay. So what we can do here? So if we calculate the determinant of AB, it is determinant of I. Now
So
determinant of I is non-zero, correct?
For which options are this one? Sorry.
Third one.
Can you just show
So
the
this is
question for-
non-zero. So this is non-zero. That means both the determinants are non-zero, right? So A is invertible. So once A is invertible, I can multiply A inverse from both sides. Okay. So A inverse A is identity. So B is A inverse. Now I can multiply A from right and I will get BA equal to identity. Okay. So what I can conclude from here, it is given that A minus identity into B minus identity is identity, right? So I can do that. So this implies B minus identity, A minus identity is identity. Correct?
Sir, if we do cross multiply and check for that.
Cross multiply.
I mean this. If we open the bracket, A minus I.
So anyway, I have to do that, but that does not imply anything. Okay. So if I open this, I will get this. Now identity will go this side, so we will get 0. So AB equal to B plus A. Correct? But I want to show AB equal to BA. For that I need this one. So if you open this. So this will give me
BA equals to A plus B.
Now A plus B and B plus A are same. So AB equal to BA.
Sir, but why is B minus I into A minus, like how can you inverse it? Like, is it possible?
So that's what I have done here, no? If A and B are square matrices and their product is identity, then I can write that BA is also identity.
Oh, okay.
Right? Because we can take determinant and we can show that both of them are square matrix first of all. Otherwise it cannot be concluded. Okay?
Yeah, okay. Thank you.
So determinant is non-zero. So A is invertible. I mean both of them are invertible. So I can multiply with inverse of any of one of the matrices. So B equal to A inverse, then I can multiply A from the right. So I will get BA equal to identity. Okay, I have used that one here. So from A minus identity to B minus identity equal to identity, I can conclude that if I take the converse statement of that, so B minus I into A minus I is also identity.
Because A is invertible, you have done this. I mean, you can.
Not A is invertible. In this case, this A minus I is invertible.
Okay.
Correct.
So, but for that also you have proved that A, I mean this A into B is determinant is non-zero.
I mean if there are two matrices, two square matrices, and the product of theirs are identity, then I can make it commute. Okay.
Okay.
That is what I am using here.
So
yeah.
So I can understand how we got A minus I into B minus I is equal to I because that's given in the question. But how is B minus I into A minus I equal to I?
That is I am telling now. If A and B, okay, so I think A and B has confused you. Suppose I have two matrices M and N. Okay, M and N. There are two matrices such that two square matrices such that Mn equal to identity. Okay. I say I am claiming that then Nm is also identity. Is this portion clear?
So because N is the inverse of M?
No, I mean is how can you show that N is inverse of M? Because that is what I want to show. If it is a square matrix, then I can calculate the determinant, right? Determinant of Mn is determinant of identity, that is 1. So this is non-zero, right? So determinant of both M and N must be non-zero. Right? And determinant non-zero means what? M is invertible and N is invertible. Correct? So M is invertible, let me write.
I just wanted to check how did we first assume that it is a square matrix because I is of order n, is it? So automatically
I is of order n and I am doing A minus I. A minus I is defined here. So A must be square matrix of order n.
So
right?
Here, so here A minus I is M and B minus I is N.
Exactly.
Okay. Got it.
Okay. Now you do it. Mn is identity. Multiply with M inverse. So your n is M inverse. Then again multiply M on the right. So this will give me Nm is identity. Okay?
Yes, sir. Got it.
Yeah. Is it clear to everyone?
Yes, sir. Sir, I have a question. Question is that so if the two matrix multiplication is the identity matrix, then one matrix is inverse of another.
Only for square matrix. Otherwise, we cannot conclude that. Okay.
So only for square matrix we can do this. AB equals to B. I mean.
Because that's why when we can calculate the determinant, that is what I am doing.
Determinant. Okay.
Yeah.
Excuse me, sir.
Mm-hmm.
I have a doubt in the procedure. One thing which is given in reflect with us, solve with us week 4.
Yeah. Okay.
Sir, one minute, sir. Sir, if we know that Mn is equals to I and Nm is equals to I, then why even do the one given below?
No, we don't know that. We don't know that. This is not given. No, I want to prove that. We have only given Mn is identity.
But we just found it out by multiplying with the M inverse and then showing that it is equal to I.
So M inverse exists. That I have to show now first. That M inverse exists.
Okay. Yeah. But we have shown it by saying that determinant of M into N is.
That's what the proof is.
What he means to say is like if we consider AI and BI as M and N, then BI and AI should automatically be proved by the above thing. So we do not need to deduct this like they do.
We not even do that AB is equals to B plus A and BI equal to A plus B when we already know that Mn is I and Nm is I. So
now here in this case, what is your Mn?
No, sir. We are given that AB is equals to like the product of A and B is I, right?
No, we are not given that.
So can you see the question for a minute? I think
we are given A minus I into B minus I is identity.
Correct, sir. But if you take A minus I as a new matrix and B minus I as a new matrix, then the standard definition for a identity matrix where product of two matrices and identity means that the reverse is also possible.
Product of two square matrices.
Two square matrices.
Yeah, that is really important. Okay.
So, but we can get a square matrix even without the individual matrices being square matrix, right? So how can we start off?
No, A minus I is defined here, right? And I is a square matrix. So how can be A not a square matrix? This subtraction has to be defined, right?
Yes, sir. So A minus I.
So A must be a square matrix, no?
Okay. A minus I is defined. So A is same dimension as I. A and B are same dimension.
A minus I and B minus I equals to 1. You are deriving that and getting AB equals to A plus B, right? And then you are writing B minus I times A minus I equals to I. Correct?
So here, can I?
This what? Here. How you are assuming that the both are equal? One? I'm saying the first term A minus I times B minus I equals to I, correct? So we are assuming that this term, first term, let it be X and second term which is Y. So XY equals to YX, correct?
So you are saying why A minus I is square?
No, sir, he's just repeating the same question that two of us asked, sir.
Sorry, A minus I is defined.
See, you have to, he already explained to you why A minus I into B minus I is equals to B minus I into A minus I is equals to I, right? You just go to YouTube.
No, so let me understand what his question is first, because I have not got what his question is.
Okay, let me just define A minus I as X. Okay? And B minus I as Y. This you are taking X times Y equals to I in the first side, left side. Right?
Yeah, right.
And the right side you are taking Y in times X equals to I.
So this implies YX equal to identity, right? That's what I have proved, no? Yeah.
If you do 2 into 3 or 3 into 2, answer will be same. I mean,
but
expansion is not needed, sir. Like,
but you are starting from a different.
Actually, can I? Sir, can I?
1 minute. What different equation?
But you are changing the equation in the first line, right? A minus I times B minus I equals to I, and B minus I times A minus I equals to I. So how you are changing?
No, first of all, tell me if A minus I is your X and B minus I is your Y, and it is given that XY equal to identity, can I conclude YX equal to identity?
Yes, given for square matrix.
Is it correct?
Yes.
Yeah, but square
Can we-
matrix is not given in the question.
No, I am claiming this XY must be square matrix.
Yes.
So can I just
1 minute.
have a thought?
This XY must be square matrix, right?
Yes.
Yes, sir. So
Why?
So
Because
A minus
is a square
so
matrix.
from the question A
So
minus I and B
identity
minus
matrix is always a square matrix. And
Identity, it is given
defined.
that identity matrix of order n, right? So it is n cross n matrix.
So one more thing is A minus
And A minus I
and
is
B
defined
minus
when
I
it is
both
must
are
be of the same order.
defined.
Exactly.
Can I finish?
Exactly.
Finish, please.
Are you having a question?
No, sir. What I was saying is A minus I and B minus I both are defined, which means A minus I cannot be done if A was different than I's dimension. So both are same.
Yeah.
A and B are A and B have the same dimension as the identity.
That's what I have said, no?
No, sir. Like actually, I'm talking about the how we can probably arrive at the proof by reasoning this way, right? A and B are square matrix.
Okay. Anyway.
So for a square matrix, you can do the inverse.
Okay.
Commutatively, you can arrive at the inverse.
Yeah. Okay. If you understand, then it's okay. Fine. Is it clear to everyone?
Yes.
Yes, sir.
Yes, sir.
Yes, sir. Great. Yeah. So week 4, solve with us, right?
Yes, sir. Solve it.
Or reflect with us.
Solve
can
it.
you finish this mock test quiz first, then we can move on? Because we are in the middle.
Is there any other question you have doubt?
Sir, in this
Yes,
option
sir,
5, sir, in option 5, should it not be 8 raised to n? I mean, in the sense that determinant of 8a, when you take 8 outside, it is basically raised to the power of.
So you are saying there is no square matrix as that this happened, right?
Yeah.
So you are saying option 5 is correct.
So I'm just saying that if you take out the
so if I take 0 matrix, is it a square matrix? 0 matrix of order 2, say.
Yes, sir.
Yes. Then the equation hold?
Yes.
Then there exists a square matrix, no?
Correct.
Even if we take just a single element like 1 in the
then also it will happen.
Then it will also.
Yeah, right.
So this condition will satisfy only for the 0 matrix, sir?
No.
0 matrix and any matrix of order 1.
Okay, fine, sir.
So what is the
disjoint
disjoint
determinant 0? It will work.
What is the disjoint subspace?
Disjoint subspace. No intersection between them.
Nothing
You
common.
know the disjoint set, right?
Nothing
There is
common.
no common element. That is disjoint.
Sir, can you fix the fourth sum, sir?
Sir, in the first
So then we use the properties, sir. Then the intersection of two subspace. It has to be
So I think you are talking about this option 2, right?
option 2, yes, sir.
Yes, sir.
So anyway, if this is a vector subspace, then 0 must be always in there, right?
Yes.
So in the intersection, the 0 vector should be there. They cannot be rejoined.
Right.
So can you
Is it
explain
clear?
the option 2?
That's what I was doing. So if we take any subspaces, then zero element must be there, right? 0 vector. That is the first condition for being a subspace, right?
Yes, sir.
So that 0 vector should be in all the subspaces. So any two subspace cannot be rejoined.
Yes,
Yeah?
0 vector is present in all the subspaces.
Right.
Yeah, all the subspaces. So they cannot be rejoined. Okay? Yeah.
And what about
I have a doubt in
option
question 3, sir.
Sir, option number 4.
First of all, have you seen, who have already attempted this mock, have you seen the solution?
Yes.
Still you have doubt?
No, sir, we have not seen the solution.
That's why. So you see the solution. Okay. And which question are you talking about now?
The fourth option,
three, sir.
fourth question number, option 1, sir.
One by one. One by one. So I am not getting.
Sir,
So
same question, sir. Same question, option number 4.
same question, option number 4. Union of two linear independent set need not be linear independent.
Sir, can you give us an example?
I mean,
It is
union of two linear independent set, no?
Yes, sir.
This is linear independent in R2.
Yes.
Okay. This is linear independent set in R2.
Yeah.
What is their union?
1 0 0 1 and 1 1.
Is it linear independent?
No.
No, sir.
No.
Have you got your example?
Yes.
Okay.
So
Then
here, can you go back a bit, sir?
Option 1, sir. A bit confused with the option 1.
Sir, here the quickest way is like to see one is the linear combination of the other two, right? For the
this last one is linear combination of the previous two.
Yes, sir. Okay.
Yeah. Option 1.
Yes, sir.
Set of all invertible matrices of order 2 forms a subspace of M2R. Okay, so for being a subspace, zero matrix should be there, right?
Yes, sir.
Zero matrix of order 2 should be there, right?
Yes, sir.
But is that invertible?
No, sir.
Is the set of all invertible matrices contain zero matrix?
No, sir.
No, sir. Okay.
So how can it be a subspace? Clear, no?
Yes, sir.
Yeah. Great.
Right. No, question
I have
3, sir.
a small problem on the wording of the option 3. There exist 3 linearly independent vectors in the R3 such that none of the above there is a multiple to another. Now I have a problem with the what 3. There should be not be 3. There is a many such vector exist. So my question would be, if question should be correctly framed, then there will be a state will be there whose maximum cardinality should be 3 to make it linearly independent.
So it is linearly dependent.
It says these 3 vectors are linearly.
So this question is there exist linearly 3 independent vectors in R3 such that those 3 vectors, whatever you have chosen, no one is the multiple of the another. Can there exist any 3 linearly independent vectors? That is the question.
So linearly dependent.
Actually, the question.
So I am taking the negative of that basically.
The question in the mock test actually says these 3 linearly. It's been edited here in this sheet.
No, this was the question. There exist 3 linearly dependent vectors in R3 such that none of the 3 is multiple of another.
Yes, sir.
That can exist, right? That is possible,
Yes,
right?
it can.
Yeah.
Sir, can I take
This is
example,
what
sir?
the question is exactly in here. First,
But sir, how it can be exactly 3? It can be any number.
But in the option, it's given as 3.
There exist 3 linearly dependent vectors in R3 such that none of these 3 is a multiple of another.
So
there can be more than 3, that is possible, but can there exist 3 vectors? That is the question.
Just taking example, okay, a rough example. You can explain, sir. We can. It will be fine, sir.
First, no, I just want to make it clear whether language is clear or not.
No,
He is asking about the language. I don't think he has a problem with the answer.
No, the language is not clear actually for me.
What is not clear here? Question is, there exist linearly dependent vectors. There exist 3 linearly dependent vectors in R3 such that none of these 3, whatever 3 you have chosen, is a multiple of another. Can there exist such 3 set? Can there exist such set with 3 vectors?
Yes, there exists. But
that's why it is correct.
But I have an objection on the term 3. There may be multiple.
There may be more than 3 vectors. That is okay. But question is can there exist a set with 3 vectors? Is it true or false?
Yes, so the problem is happening that there may be some questions where that 3 is become a bottleneck, and the question examiner can say that no, there is.
Amitabh, let me explain it.
If it was that exactly 3, I think then it could have been a problem.
I think he is asking for there exists only 3, that type of.
Only 3 or exactly 3?
Only exactly 3.
The statement is saying there exists 3 linearly dependent vectors in R3 such that no one is the multiple of other, right?
Yes, this is a correct statement. Clearly correct statement.
That is written here. This is exactly what I am saying. Okay, I mean.
There is three linearly dependent vectors. If we have two, then it must be a multiple of each other. No.
The point here is the existence of that set. Can there exist such a set? If it is yes, then the answer is option 3 is correct. If does not, if there is no such set, then option 3 is false.
So the answer is correct, right?
Yeah, answer is correct.
This is correct. Just I am saying that if, there are two linearly dependent vectors, then it must be multiple, no?
Multiple of each other, exactly. But for 3, it is not mandatory.
Yeah. For 2, it is must be.
Exactly.
Sorry.
How for 2 it is must be multiple?
If a set of two vectors are dependent, then one must be multiple of other, right?
So sorry to interrupt, but like as you
We
mentioned,
then say that it should be a linearly dependent set and not just linearly dependent vector, sir.
When I am talking about a set, then when I am talking about linearly dependent set, that means the vectors are dependent on each other, right?
Right.
That's why we call these linearly dependent vectors.
so as you have already provided the solutions to these mock tests, could you please like solve some multiple different type of questions which would be important for us in exam?
Mock is really important. If you go through the mock well, I think quiz will be easier for you.
Yes, sir. We can have a look at the mock
Quiz we
solutions.
will have. Sorry, excuse me, sir. In quiz, we will have the same number of questions, and there will be
that
some
may not be.
questions.
I mean, pattern will be more or less same. Okay?
Pattern
I have a question here, sir, regarding the reduced row echelon form Gaussian elimination.
But that I have explained in the last session, right?
Just one small clarification, sir. So, or any row echelon form, whether reduced using Gaussian or any other method. So, my question was, I have seen a lot of this one while doing the calculations. We might get an intermediate matrices slightly different, but is it correct to say that finally when you arrive at your reduced row echelon, it will be the same?
Then it will be same. It will be same. Whatever you do, the final form will be same.
Okay, fine. Thank you.
Sir, I have a doubt, sir.
Yeah.
Sir, if 3 vectors are linearly independent, and if we introduce a new vector, fourth one, which is dependent for the 3 vectors, then we can, it will be in the span of S, sir.
Yeah, right.
How, sir? How can you say that? I couldn't understand that point, sir.
So, suppose your S is this is linearly independent, right?
Yes, sir.
You enter another vector and you are getting this set now, and you are saying it is linearly dependent, right?
Yes, sir.
What does linearly dependent means?
The 3 vectors are in the linear combination.
These 4, there are 4.
Yes, sir.
So linear dependent means there is a linear combination of these 4 non-zero linear combination, so that it makes 0, right?
Yes, sir.
Like this. Okay. Correct?
Yes, sir.
This is a non-zero linear combination. Okay. Now your question is V4 in span of S. Correct?
Yes, sir.
So can V4 be written as linear combination of V1, V2 and V3?
Yes.
Yes.
Why?
Because it's
no, sir.
Yes, it can.
Yes, because they are
Is it always true?
No, alpha 4 can be
their
0.
R3. Not always true. Maybe if it is defined in R4, I don't know.
No, alpha 4
No,
can be
it is
0, right?
linearly independent, it is already given. Okay, and this is linear dependent. So
this is true.
Why?
V4 is a multiple of them.
So if V1, V2, V3 are independent, then V4 will be a combination of V1, V2, V3, sir. I mean linear combination of V1, V2, V3, sir. So it can be written as a, this is true, I think so.
Well, can you show it?
Yeah, sir, I can show it.
Yeah, how?
V1, V2 in span of S, there will be one that for V1 is 0, V2 is 0, V3 is 0, and for V4 there is one alpha, and whatever that is in if alpha is 1, then V4 is there.
Can you repeat it?
Yes, sir. V1, V2, and V3 are linearly independent. So alpha 1, alpha 2, alpha 3 are zeros. But if linearly dependent, if the four vectors are linearly dependent, then one must be non-zero.
Suppose this one is non-zero, alpha 2, then?
But it is
Suppose
given that
alpha 2 is non-zero, then?
So it means so if alpha 2 is non-zero, so I think V4 is a combination of alpha 2, I think so. Multiple of alpha 2.
Multiple of V2.
Sir,
Yeah, A2,
if
yes.
alpha 2 is non-zero, then V4 be alpha 2 by alpha 4 V2.
Why? No. Suppose these three are non-zero. Alpha 1, alpha 2, alpha 3 are non-zero. Then? And alpha 4 is 0.
Alpha
Then?
4 should be non-zero, then we
Exactly. Alpha 4 should be non-zero. Why?
then we can express it as a linear.
Exactly. But why alpha 4 must be non-zero?
Because V1, V2, V3 are linearly independent.
Exactly. If alpha 4 is 0, suppose alpha 4 is 0, okay? Suppose. Then what I am getting from this equation?
They are all everything is independent.
This is 0, right?
All are
Then
and
all are 0.
Determinant A1, A2,
Then, yeah, then this all these three must be 0. That shows this is linearly independent. V1, V2, V3, V4. But that is not the case, right?
Yeah, sir.
Yes, sir.
So alpha 4 must be non-zero.
Right.
Correct?
Yes.
Yes, sir.
So what I can do here, I can take V4 equal to minus alpha 1 by alpha 4. I can divide by alpha 4, right? Because alpha 4 is non-zero. Right? I think you got the gist.
Yes, sir. Yes.
So V4 can be written as linear combination of V1, V2, V3. Okay? So it is in the span of S.
V4 is in the span of S.
Sir, I have one doubt.
So, but alpha 1, alpha 2,
Since
alpha 3,
alpha 1,
all the
alpha
three
2,
will
alpha
be
3 is
0.
already 0, and if we are dividing by alpha 4, then that will also be 0, right?
Okay, then V4 is 0, no? So if V4 is 0, then obviously it is in the span. Whatever the case you are telling, if alpha 1, alpha 2, alpha 3 all are 0, okay, then V4 is 0, correct?
Yes, sir.
And if V4 is 0, then it is obviously in the span of S.
Yes.
But the coefficient of V4 need not be 0. That is the point.
So without doing this much, can we say like
V4 is a 0 vector. I mean, like which is 0, right?
I mean, if all these coefficients are 0, then only V4 is 0 vector.
Yeah, that's what I'm saying. So that V4 will become 0.
Yeah, right. Yeah.
without
Is it clear to everyone? Yeah, Sandeepan?
Yes, sir. What I'm saying is if alpha 1 V1 plus alpha 2 V2 plus alpha 3 V3 plus alpha 4 V4 equals to 0, and if V1, V2, V3 is linearly independent, then V4 is the dependent one, is a linear combination of V1, V2, V3.
So it is defined on R3.
Span of
That
A,
doesn't matter.
Sorry, sir.
Yeah, Sandeepan, go ahead.
I'm saying then span of S will contain alpha V1, V2, and V3 only.
Yeah, that's what I have proved here, basically. That is the proof.
Okay.
That is the proof what you are saying. That is the statement, and this is the proof of that. Okay?
Okay.
Yeah.
Sir, but how can V4 be linear combination of these three? Na? Because if V4 is a non-zero vector, and alpha 1, alpha 2, alpha 3 are already 0, even though alpha 4 is not 0, how can we show that V4 can be a linear
No,
combination?
that is the point. When alpha 1, alpha 2, alpha 3 is 0, then V4 must be 0. It cannot be a non-zero vector.
Okay.
That's what I am saying, no? And in that case also it is in the span, right?
Right. Yeah,
Because any zero vector is in the span.
Yeah. Okay.
Clear?
Yeah.
Yes, sir.
Okay, great. Okay. Yeah. Any other doubt you have?
Sir,
Can
so
V1,
if
V2,
V4 is
V3
0,
be?
as per we
one by
concluded
one.
yeah, sir, as per we concluded that V4 is 0, and then
No, we
the
have not
method.
concluded V4 is 0. Okay. My conclusion is V4 is in span of S. That is the conclusion. V4 may or may not be
Yes,
0.
because in when alpha 1, alpha 2, alpha 3 will be 0, V4 will be in the span of the vector.
No. See, when I am writing this implies V4 is in the span. Whether it is 0 or non-zero, it does not matter. That's what my conclusion is.
Okay.
Okay?
Okay.
Yeah.
Sir, any vector written as a linear combination of the other three vectors, that dependent vector V4 will be in the span of S.
That is the definition of span.
So is it
Span
necessary
means
that
linear combination of the vectors, right?
sir, so in that case, is it necessary that every vector in the spanning set should define every
Should be a
other
linear
vector?
combination.
Linear
What
combination.
is
The question is, if we have to add a vector to an existing linearly independent set, are we sure that the set that we have taken
no? If it is
the
becoming linear
the
dependent,
maximum?
then if it is becoming linear dependent, then only we can conclude that.
Okay.
So, my question is from the spanning set. Is it necessary that all the vectors in the space should have a linear combination of all the vectors, or a few vectors from the spanning set?
What do you understand by linear combination?
I mean, like you have a coefficient, you add up the vectors and the
Is this a linear combination of V1 and V2?
Yes, sir.
Then V1 and V2 are independent. If it is equal to
It doesn't matter. I mean, is
No,
this a
my
linear
question-
combination of V1 and V2?
Yes, sir.
So have you got your answer? What you are saying?
So my question is from the spanning set. When you have a spanning set for a vector space, so talking of the spanning set, does it mean that every other vector should
Here, what is happening? I mean, if something is 0, you can just put it off. No, like this.
No, I understood, sir. What I'm saying, my question is general, sir. I'm not related to this one from the spanning set as such. What I was
I
saying
am
is,
also doing first. Okay, go ahead.
yes, sir. From the spanning set, is it necessary that all the vectors have to be taken for defining every other?
Some
vector?
coefficient may be 0. Some coefficient may be 0. That's my point.
Yeah. Krishna Mohan, that's what he is trying to say. Like, each and every vector need not be there. Like the coefficients be 0. That time you don't need to.
What does coefficient 0 mean?
Yeah, there is no vector.
There is no vector
need
of that.
That vector may not be in the combination, right?
It's the combination. Yes. Okay. So
got it. You got your answer.
Yes, sir. That in the sense that not all vectors need to have the coefficient non-zero, right?
Correct.
Thank you.
One question, sir.
Yeah, go ahead.
So when can we say that V4 is not in the span of S?
I mean, this is what is your question? Can you just phrase it properly?
So, like here we have stated that V4 is in span
So
of S.
V4 is also, after adding V4, if the set is again linearly independent, then V4 is not in the span. Right?
So you mean to say spanning set should be linearly dependent? Maximum spanning set?
No. Minimum spanning set should be linearly independent.
No, maximum spanning set should be linearly dependent.
Maximum, there is no concept for maximum spanning set.
So in this case, we are approaching the state where we get a linearly dependent set.
See. If I am taking this is my S, okay. Suppose I know this is linearly independent, okay.
Yes, sir.
I am adding one more vector, okay. So my set is V1, V2, V3, V4, right? If this is linearly independent, then V4 is not in span of S. Is it clear?
Okay.
No, who is asking that question? Is it clear?
Yes. Sir.
Why V4 is not in the span?
Because minimum spanning set is already there.
V4 cannot be explained as a linear combination of V1, V2, V3.
Then it is becoming linear dependent, correct?
Okay, sir.
But I have
Spanning set
taken this
itself
as
means, yeah, spanning set is itself means that we need to have a linear combination of each other. That's what are you trying to say?
no. If V4 is in span of S, then what does it mean? Then V4 is a linear combination of V1, V2, V3, right?
Right.
But then this set becomes, so I can get a linear combination like this, which is giving me 0. So this V1, V2, V3, V4, this is becoming linearly dependent, right? But I have started with linear independence set.
Right, sir.
So it cannot happen, right?
Yes, sir.
Got it, no?
Okay. Yes, sir.
V4 is not in the spanning set of S, but V4 is in the new set, which is the union of S and V4. It is in the spanning set of a new set. Let us say some other
Spanning set. No, if you understand this by your own way, then it's okay. But whatever you are telling, I am not getting what does that mean.
Sir, I tried to say this only, like we need to get to the stage where we get a linearly dependent set.
Then the previous, then that new vector is in the span of the previous set.
Yes, sir. Till then, we need to append the vectors, all the vectors linearly.
Basically, we are doing going up to maximal linear independence set.
Yes. Okay.
Okay.
Sir, if
yeah, go ahead.
Sir, that suppose that we are given linearly dependent set and we add and we do the union of S union V4. Then, sir, what should be?
Then again, it is linear dependent.
Okay, sir. Sir, the and we have come to a conclusion that it should be linearly dependent.
If you are starting with linearly dependent vector and if you add another vector, then obviously it is linearly dependent, no? Because the previous set is always linear dependent.
Yes, sir. Okay, sir.
Yeah.
So,
I have a question in the AQ 3.3.
Sir, fifth question, sir. Fifth question.
Sir, we are discussing mock tests. I think, sir, we have a PDF solution. I have a question in AQ.
But everyone's doubt should be clear, no?
Okay.
So let me go one by one.
So mock second.
Sir, mock question number 3.
Sir, I have a doubt. I still have a doubt in this thing, sir. So we know. I'm sorry for repeating this again, but we know that spanning set is nothing but a linear combination of vectors. Linear combination of vectors.
Okay.
Right?
Yeah.
So it can either be linearly dependent or linearly independent, right? The spanning set can be linearly dependent or independent. Is that right, sir? It is right.
I mean, spanning set can be linear independent. It can be linearly dependent.
Yeah. Then why is it a problem if I add a V4 to a spanning set that's already linearly independent and I add a V4 to it?
No, that is not a problem. No, that's what I have shown here.
So that is not a problem, right? So
can I give you
I got confused by people asking it again and again. So that's it.
Okay. So yeah.
Can I ask a question?
Sir, please take a real example, sir. So see, people are asking same question again and again, sir. Every
Can
time.
I give you an example,
only,
sir?
Yes, sir, exactly. You can write 1 0 0 0 1 0 0.
Yes, R3. You can give an example of R3.
Excuse me, sir.
Yeah.
1 0 0 0 0 1
any
0 1
spanning
1.
set which forms a basis has to be linearly independent. Basis of say R3.
What is the definition of basis?
Basis is basically a set which forms a basis for every other set in that plane.
What is the definition of basis?
Minimal spanning set.
You just go through the lecture once, okay?
Linearly independent.
Linearly independent and?
It forms
and it
spans, right? So you are saying it is linearly independent.
Okay.
Yeah. So no, here two types of question has been asked. I don't know whether all of you got it or not. This is not about only for example, okay? So yeah, even if I take this example, this is linear independent, correct?
Yes.
So in R3 there is a border, so let me go till R4. Okay. So in R4 also this is linearly independent. This is my set S. Okay. Now if I add another vector, okay, when I am explaining something, can you please hold your question for a bit?
Yes, sir. Sir, please don't interrupt when Sarah is speaking. The flow is getting.
So this, if I add this vector, okay, is this set linear independent?
Yes.
Yes, sir.
Yes.
Yes. Okay. Second question is this vector in span of S?
No, sir.
No, sir.
No.
Yes.
Okay.
No.
No, it is not in span, right? You cannot write this as a linear combination of this. Okay. Now another question is, if I add this vector, is this set linear dependent?
Yes, sir. It is linear.
Yes.
It is linearly dependent, right?
Yes.
Yes, sir. For that matter,
Now
any vector.
When I am explaining, can you please hold your question for a bit? Yeah. Is this in span of S?
Yes.
Yes.
Yes, sir.
Yes, sir.
So these two type of question has been asked here. So in a spanning set, suppose I am starting with some linearly independent set, okay? And if I consider the span of this, now if I add one more vector, then if it is in the span, then the new set is linearly dependent, okay? If the new set is linearly independent, then the new vector is not in the span. Is it clear?
Yes, sir.
Yes, sir. Crystal clear.
Could you just
So
repeat,
now-
sir? It's confused. Can you repeat, sir, please? Just this one is very important.
Who is asking that?
No, myself, Krishna, sir.
Okay. What is your doubt here?
Regarding adding these vector to the span.
So what I am saying is, suppose I am starting with a linear independent set, okay?
Yes, sir.
Yes. This is my linear independent set. Now, if I add a new vector and the union is, I mean, after adding a new vector, if the set is linearly independent, then whatever the new vector I have added, that is not in the span of the previous set. Okay, this is the first point. Okay. Now, after adding a new vector, if the set is becoming linearly dependent, that implies that the new vector which I have added, that is in the span of previous set.
Okay.
Yes. It is clear?
Yes, sir.
Brilliant. Yes, sir.
So now if we start with linearly dependent set, then what will be the changes?
Then whatever the vector you add, it will be always linearly dependent.
Okay. And that
because
will be in the span
your
of
previous
S.
set is linearly dependent, no? So it doesn't matter whatever vector you are adding.
Okay. Got it.
Sir, just so that I can get it clear, let me just repeat what you said itself. So
okay.
We have this basis, right? 1, 0, 0, 0, and
no, I am not talking about basis here. Okay.
But it is the basis, right? The three
basis of what? This is basis of what?
Obvious, right?
Okay, go ahead.
That is the basis of S, and then you add a vector.
Not basis of S. That is the basis of span of S.
Okay, sorry. That's the basis of span of S, and then I add a vector 0, 0, 0, 1 to the S, but it won't be in the span of S because it makes the so basically we can't span S. We can't span this vector using the three basis vectors, right?
Exactly.
That's why it is not in the span of S. So basically, this goes to the basis of S, or it won't go to the basis of S, depending on what you're going to do with it.
No, this does not go in the basis of span of S.
Okay.
Because span of S is already fixed. It has dimension 3. Now we have one new vector. Now span of this whole thing will be a new vector space.
Yes. Okay. Okay, sir.
Got it, no?
Yeah, I got it. Thank you, sir. Thank you so much.
So,
okay, yeah.
So the quiz one will be similar to the mock, right?
Similar to the mock. Not exactly similar, okay? I mean, more or less the concept which we have discussed here, that will be in quiz one.
The questions
I have a question in question 5, sir. 5, option 2.
Yes, sir. For me also, sir.
So I have one question.
In 5, option 2.
So can
go ahead.
suppose we are given a linearly dependent set and we need to make it linearly independent by removing one vector. Normally it requires heavy calculation. Is there an easy way where we can find out or a trick where we can remove one vector?
So the general thing is doing row reduction.
Okay, great. Thanks, sir.
Yeah.
Can I ask a question on question 5, sir? Mock. Question 5.
Question 5 I have already explained, I think.
Option 2, sir.
Option 2.
That I have already explained at the beginning of this session.
So
Yes.
It is already explained, so we can listen to YouTube lecture later if we have
Yeah.
same
Yeah.
question. We are
Sir, I have
wasting
seen
time
the
over here.
recording, but I still have one small doubt here. Can I ask that?
Yeah, go
So,
ahead.
so if here dimension would be 2 and then it will be the correct option, right? Dimension of span of S would be 2.
If you have some set and dimension of S is 2, I mean S is from R3, S is a subset of R3 and dimension of S is 2, then span of S must be a proper subset of R3.
Yeah, suppose 201 would not be there, then this option would be correct.
Yeah.
Right? Okay. Thank you.
So only question that I had on 5, sir.
it would become a plane.
Sorry, sir.
So
Only question
Can
on
you talk one by one? Then it will be
so
easier.
once we are done with the graded and practice assignments and the mock, what do we do, sir? I mean, where do we practice sums from? It's like we're repeating the same sums over and over again.
Have you completed all the questions for graded practice, activity, solve with us, reflect with us, matching problem and mock?
Yes, sir.
Yes, sir.
Then you have to do nothing. You can easily do the exam. Okay.
So will we have another mock?
No.
No.
So excuse me, sir.
So on that question
Here,
5.
if 201 is not there, S contains only 1 minus 1 0 0 1 1. It is a spanning set.
Spanning set of what?
Spanning set of this 1 minus 1 0 and spanning set of R cube.
No, it is not a spanning set of R3 because can you expand? I mean, what is the dimension of the span of S in that case?
2.
2. And what is the dimension of R3?
3.
So it is a proper subspace, right? So there are some vectors in R3 which you cannot span from these two vectors.
So
but it is a spanning set. That's it.
Spanning set of some vector space.
Okay.
It is not a spanning set of R3.
Okay, so spanning set of something other than R3.
Yeah.
Subspace of R3.
Subspace of R3.
So I have a question, sir. In this option 2, how did you get the coefficients? Because in the solution you have, showed that it is not a proper subspace by using the coefficients. But you have shown that it is not a proper subspace by using coefficients, and you have said any.
So my point is, first of all, tell me what is the dimension of span of S? Can you tell me that?
That is 3, sir.
Why?
Because the 3 are linearly independent.
Okay, so it is till now, till that point it is clear, right?
Yes.
So you are getting 3 linearly independent vectors in R3.
Right.
Okay.
Right.
Okay. Now, so it is a basis of R3. Is it clear to you?
Yes.
If it is a basis of R3, then every vector of R3 can be, written as a linear combination of these 3 vectors.
Right.
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 So can span be a proper subspace? Proper means what? There should exist some vectors in R3 which you cannot write as a linear combination of these 3 vectors, right? In that case, it should be proper.
I understand that concept, sir. My question was, in the provided solution PDF, you have created the coefficients of any arbitrary vectors.
ABC, in terms of ABC, right?
In terms of ABC.
So that is just a solution. That is the solve the system of linear equation and you will get that. You write ABC as, okay, so take ABC. Write is x into the first vector, y into the second vector, z into the third vector. You will get 3 equations, right? Linear equation. Right?
Yes, sir. Yes, sir.
No, is it difficult? Is it to write it 3 linear equation from here?
Yes, sir, but I get x plus 2y, whatever.
Whatever the equation you get, now solve it. Solve for x, y, z. Using Gauss elimination, you will get the coefficient.
Okay.
That is usual process, right?
Yeah.
Yeah.
So I have a
Go
question.
ahead.
Activity questions. 3.3.
Can you explain proper subspace again?
What is proper set? First of all, tell me what is proper set.
So a subset which has lesser elements than that capacity.
I mean, there. So I have taken suppose T and S. So I will say T is proper if there exists some element of S which is not in T, right? So S is itself as S is a subset of itself, right? Okay. Similarly, for vector space, when I am saying that W is a proper subset of V, subspace of V, here I am taking subspace. That means there exists some vectors in V which is not in W. Same definition. Okay. So when it is a proper subspace, then dimension of W must be strictly less than dimension of V. Okay. Is it clear?
Yes, sir. Good.
So can you show us? So can you show us how?
So see, suppose I am taking R3. Okay. In R3, if I am taking span of these two elements, the span of this. Suppose this is my W. Okay. Is W a proper subspace of R3?
Yeah, dimension is
Yes.
Yes.
Okay. So what is W? If you can see, W is basically XY plane, right? So it is proper, right? You cannot write any element on this Z axis by these two elements. Okay?
Yes,
so it is a proper subspace. Clear?
Yes, sir. So can you show how to find if three matrices are independent?
Same thing. Yes. So suppose I have taken this. A, B, C. Then you have to equate it to 0 because this is the 0 vector in matrix space.
So,
Okay?
so actually, I was talking about row reduction method earlier. One of the sirs did it, and I was just confused.
Okay, so you are talking about vectors. If you write the vectors in matrix form, then do the row reduction. Then whatever the non-zero rows are there, that will give me the number of linear independent vectors, right?
No, so that so kind of made matrices into vectors and did row reduction.
So here, what's the equivalent for the vectors here? Matrix, you are doing the addition here. So
Can you give me a proper question?
Yes, so here you written a matrix, a linear combination of these two matrices, right, to equal to 0 matrix. So how to
let me talk with him because he is asking the question.
So no, so so kind of translated the matrix this into into vector space of R4 and did row reduction.
Who has done it?
So earlier in one of the classes.
Okay. Basically, that is not required for this course. So we can think this matrix as a vectors in R4, 1, 0, 0, 0. This as a vector in R4, like this. Okay. So then you can talk about the linear independence, but that is the same as doing like this.
Okay, sir. So either way we can get the...
Yeah, either way you can get it. But this transformation is not really necessary for now.
Okay, so right now we'll just be concerned with multiplying a scalar and equating.
Yeah, that is exactly the same thing.
Okay, thank you.
Yeah.
So can we go to solve with us week 4?
Okay. Solve with us, which one?
Week 4. So,
yeah.
So in the key point 3, what is the procedure? Key point 3.
3.3, this one, right?
Key point 3. Scroll a little
Key point 3.
down.
This one. Oh,
Yes.
this one also I have explained in the previous session.
Yes, without this procedure, can we do this?
Yeah, any procedure, whatever you feel comfortable. This is one of the procedures.
Oh, it's not mandatory to follow this.
No.
Okay,
If you are getting by at your own, then it's okay. No, this is one of the procedure we have mentioned.
Yes, and then last one, key point 4. This one.
All of this, I mean, if you are getting in some different way, it is okay.
Okay.
But this is the standard procedure which we generally follow.
Okay, sir.
Okay. Yeah.
Yes, sir. Okay.
Yeah.
Yes, sir.
Yeah.
Question number 6 from mock test.
One by one.
So question number 6 from mock.
Have you seen the solution?
Yes, sir.
So, yeah, sum of diagonal entries is 0. I think I have already done this in one of my live sessions, the earlier live session.
This is done many times in the session.
Yeah, right.
Yes, sir.
So, diagonal matrix means what? Sum of diagonal entries are 0. So, in 3 cross 3 matrix, so this is A, B, C, D, E, F, G, H, I. It is the general form and there is a condition that the sum of diagonal is 0. This is your set, right?
Yes, sir.
Yeah. So can I write it like this? A, B, C, D, E, F, G, H, and I can be written as minus A minus E, correct? Where this A, B, C, D, E, F, G, H, all these are coming from real number, correct? So if you want to write a basis, what will be your basis? For each free thing, you will write 1 and all others 0, right?
Yes, sir.
Like this. So you will get 8 elements because there are 8 free variables. Correct? So the cardinality of basis will be 8. So dimension will be 8.
So we don't have to write all these things.
Sir, I have a doubt, like what is the difference between dimension and cardinality over here?
Dimension of a, cardinality of a basis is the dimension. That is the definition.
Okay, sir.
Great.
So can you write down one set?
I had one now.
S equal to?
I have it.
One by one.
Yes, sir. S equal to 1, 1 and 2, 2. Sir, is this the spanning set?
Of what?
Of R2?
Is it? What is the dimension of span of S?
No, it is not.
No, it is like.
First of all, is it linearly independent?
No, sir.
It's dependent.
So, what is the dimension of span of S?
I think it's 1.
1.
It's 1, right? Because 2, 2 is can be written as a linear combination of 1, 1, right?
So we need to have linearly independent sets in span of S.
No, when you are talking about basis, you must have linear independent set, na?
Okay. No, if we do not talk about basis, can we say it is a spanning set?
Spanning set of what? When you are talking about spanning set of some space, that means what?
Of R2?
No.
Okay, we can say it is a spanning set of R1, right?
Not R1. It is some spanning set of some subspace of R2. It is basically spanning set of this.
Okay.
This is a subspace, okay? W. So yeah, S is spanning set of W. I mean span of S is W. We can write it. But the dimension of W is not 2, it is 1. Because in this spanning set, this set is not linearly dependent. There is one linear independent vector.
Sir, okay, that means if we want to say that a particular set is a spanning set of R2 or R3, it should have dimension 2 or 3.
Yeah, obviously.
Okay. Sir, I
But
got
this
confused.
set, this AC is, we can write it as a spanning set. Okay? Because AC is spanning set of W. That is okay.
Yes.
It may contain some linear dependent vector. Okay? But dimension will not be the whole cardioidity of S. That is the point.
So you written
Okay,
W as
sir.
what, sir? X and K. What is it? I didn't understand.
X and X. X comma X.
X comma I. Okay. Sir, I
Got
have
it,
a
sir.
question from me. Activity question, sir.
Yeah.
3.3, sir. Actually, there. AQ 3.3. I have to go back. Question 6, sir. Question 6. Yes, sir. So here, actually, the first and second option is.
I think this is also explained many times here, no? In live session.
Sir, maybe I missed the session, sir. Actually, like.
Can you go back and okay? What is your doubt? Let me just share it.
So, yes, sir. So first and second are wrong. I didn't understand first and second.
Have you tried it?
I tried it out, sir. I have written like 1 second. I want to do this. 1 second, sir. I'm opening my this one.
Here, how V2 is a linear combination of V2?
So what here is given? If V be a vector space and V1, V2, V3 and V4 is in V and V1, V2, V3 are in V, okay. If V1 is linear combination of Vi for all these, okay. That is V1 equal to A, V2, okay. Then V2 is linear combination of Vi, I mean, okay. So
because 1 and 2, I thought I didn't understand why options 1 and 2 are
V1 is written as A V2, B V3, C V4, right? So from here, can we conclude that V2 is a linear combination of? That is the question, right?
Yes.
V1, V3 and V4. Right? This is the question, correct? Yeah. So can you conclude? What do you think?
Yes.
V2 is linear
You
combination.
can just
Yes,
take
sir.
it to one side of the.
Yes, sir.
So here ABC are any real number, okay?
Yes, sir.
What happens if A is 0?
If A is 0, then V2 is not a
So
linear
will be
combination.
eliminated.
Then V2 is not a
V1
linear, may not be a linear combination, right?
V4.
Yeah. Have you got your answer? If this A is 0, then it cannot write V2 as a linear combination of V1, V2 and V4, V3 and V4. Correct?
But the option is given. One of the options was V2 is a linear combination of V2.
That is always true, no?
Yes, sir. 3 and 4 are
V2
okay.
is
Sir.
1 into V2, so it is a linear combination of V2.
Yes, sir. V1, V2 is okay. So first and second, there is V2 is a linear combination of 1, 3, and 4. I mean V1.
That may not be true, right? Because how it can be true when A is 0? There is a possibility, right, that A can be 0, right?
Oh, okay. Okay.
But in that case, V2 is not a linear combination of V1, V3 and V4. Let me take an example. Okay?
Okay.
I am taking in R2. Okay, so let me take an easy example first. Okay, so this is V1, V2, V3, V4. Can I write V1 as a linear combination of all these three? Yes, we can.
2, 3 minus 2. Okay. Minus 2, 1.
Okay?
Yes, sir.
So this is your A, this is your B, this is your C. Correct?
Yes, sir.
Now my question is, can V2 be written as V1, V3 and V4?
So you have to bring it to one side, no? Left hand side.
But this is 0, no? Can you do that?
Oh, okay. Coefficient is 0. So
this cannot happen, right?
Okay.
You cannot find any X,
okay,
Y, Z so that you can write it. You cannot find that. Why? Because any combination will give you X plus 2Y plus 3Z, comma 0. But here it is 1. So there is no solution, right?
Okay. Yeah.
For X, Y, Z. So 0, 1 cannot be written as linear combination of V1, V3 and V4. Is it clear?
Okay. So you should bring it basically to the left hand side and check. That's a option like we have to try, right?
Have I done that?
No, here, sir. Yes, sir. Here.
Why? Where I have done that?
No, sir. When we have written the linear combination of with 0, 1, 2, 0 and 3, 0 for 1.
No,
0.
first of all, tell me, is it clear to you that V1 is a linear combination of these three?
Yes, sir. That line is clear, sir. I'm coming to the next one.
Next one, what I am doing, I am trying to write this as a linear combination of these three. I am not taking something on the left or right, okay?
Yes,
I am just writing a new equation.
Okay.
Is this set of equation has any solution?
X of 1, 0, 2, 0, 3, 0. No, sir.
No, why? Because in second coordinate there is 0 and here in second coordinate there is 1. So 0 cannot be equal to 1, right?
1, yes, sir.
So there cannot be any such solution, so that we can write 0, 1 as a linear combination of V1, V3 and V4.
Yes.
Is it clear?
Yes, sir.
Okay, great.
So I have a
Thank you, sir. Thank you, sir.
Yeah.
So suppose you're given a single vector ABC, say in R3, that will be linearly independent. I saw one question where it says ABC, but it's in R4, so that will be linearly dependent. So can you explain how is that, sir?
I am not getting your question. Can you repeat once?
Single vector, say ABC in R3 will always be linearly independent.
Any single vector is always linearly independent.
Right. So, but it is R4.
It is not. So, if I taking this vector, this is not in R4.
Okay. Actually,
can it be in R4? I mean, this is a vector in R3.
No.
No?
R3 it is.
This is in R3, right? So, this set, ABC, this is linearly independent in R3.
Yes.
Okay?
Okay.
Okay, great. Yeah.
Sir, in row reduction, if the first row is 0, 1, 2, 3, and the next row is 1, 2, 3 and 1, 2, 3. So if the first row is 0, then what should we do?
First of all, you can interchange two rows. That is possible. No?
Okay.
Suppose 0, 1, 0, and here it is 1, 2, 3. Then you can interchange these two rows.
And if
to make the first pivot element as 1. Correct?
So if all of them are 0 in this column,
all of them is 0.
Yes.
Then start with here.
Okay.
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 Sir, I have a question. Can I ask?
Yeah.
Sir, in mock test, there is one question saying that if in a 3x3 matrix, if the sum of diagonal entries are 0, then what is the dimension of the vector space?
No, 1 minute. The last one who has asked me this row reduction business?
Me.
Yeah. So what is your doubt exactly? I may have missed something.
In one of the questions in the mock, it had the 0 in front. So I just want to know what I should do with.
If all the rows are all the columns, all the elements of a column is 0, then you should ignore that column and start from the second column.
Okay.
Okay. Yeah. Great. Yeah. Go ahead. Next.
Yes, sir. I was asking, sir, the sixth question in the mock for quiz 1, where there is a vector space.
Just now I have did it, right?
Okay, it is did it. Okay, okay.
Just now I have done this.
Yeah, you did.
Yeah.
Okay, I joined a little bit late. Okay, sorry.
So you just go back and see it. Okay.
Okay, sir. Thank you.
So can we
Sir, I
find
want
out?
to ask one.
I have a doubt.
So I have a question. So looking at the linear equations, can we find out if a linear equation that
My
means
doubt is like sometimes
Sonakshi, I am not getting your voice. Your voice is breaking. So.
Yeah, sir. So
sometimes we are
it's
taking the red and sometimes we are
Sonakshi, your voice is breaking. I am not getting your voice properly.
Voice is not clear.
Yeah.
Sir, a set of linear equations are given to us, and can we find out if if that system have?
I am not getting any of you
whenever
properly
we are
now.
supposed to calculate the dimension.
Can somebody tell me what she is asking? Can anyone getting this?
No, not getting that.
So can I ask? Am I audible?
Okay, 1 minute. Yeah, go ahead.
Sir, a system of linear equations are given to us, and can we find out if that system has infinitely many solution or no solution by looking at its determinant?
Okay, not always. Okay, so if first of all, if you have 3 variables and 3 equation, then only you can calculate the determinant. Okay.
Yes, exactly.
Now, if you calculate the determinant, you will only know that whether it has a unique solution or not. Okay?
Yes.
So if determinant is 0, you can only conclude that there is not unique solution. So there are 2 possibilities that may have more than one solution. I mean that may have infinitely many solution or no solution. But exactly which one is the case, you cannot conclude from there.
That we have to conclude using Gaussian
From
elimination.
Gauss, yeah, Gauss
Okay.
elimination.
Okay.
Gauss elimination. That augmented matrix.
Right.
Yes, correct. Thank you.
Sir, I want to ask one question. Sir, practice assignment 4, last question.
Okay, have you seen the solution?
Yeah, yes, sir, I have seen.
Okay, great. Practice 4, last question.
Yeah.
So this is comprehensive type question, no? Yeah.
The question number 9, sir, I'm not able to get option number 1 and 2. How 1 and 2 are correct options, sir?
In solution, it is written, no? I mean, there nothing you have to do in as such. Which of the following set is basis of S? It is the question, right?
Yes, sir. It is a question.
I mean, just
I
let me know
understood
what is
that.
your doubt, first of all.
Yeah, sir. Correct option are option number 1, 2, 4, and 5. I am able to get option number 4 and 5. I understood that how option 4 and 5 are answered, but not able to understand about option 1 and 2.
So, first of all, have you find a basis for S? Have you find any basis for S? Hello? Have you find any basis for S?
Sir, your
Am I audible?
Yes, sir.
I think it's my problem at Wi-Fi.
Have you find any basis for S?
Yes, sir.
What is its cardinality? What is its cardinality?
Give me a second, sir. I'm checking in my copy.
So I think you will get the cardinality as 3. Okay. Now can a set which has cardinality less than 3 be a basis of that?
So can you just repeat cardinality is 3? Yeah.
If the cardinality of that basis is 3, can there be any set which has lesser cardinality be a basis of that?
Sir, I just want to say one thing, sir. Sir, right now I'm confused, sir, very much confused in this.
Forget this question. Okay, forget this question.
Yeah.
Just let me, so suppose for a vector space V, okay, you have find a basis, okay, which has 3 elements. Okay, so this is your one basis.
Yes, sir.
So the cardinality of this basis is 3. Okay.
3.
Now suppose you have given another set which has 2 elements.
Yes, sir.
Okay. Can this be a basis of V?
Basis of B?
V.
No, sir.
No. Why? If it has to be a basis of V, then cardinality must be 3 because the cardinality is the dimension and that is unique for all the bases, right? So all the bases of V must have 3 elements. Clear?
Okay.
So by just seeing
Sir, for any
this option, you can
all
conclude that
bases will have same dimension, right?
Okay, that's why
all bases
in
must have
option
same
1
cardinality.
cardinality is
That's why dimension is well defined.
Okay. So in
But
first option cardinality is 1, in second option cardinality is 2, so it is not.
By just seeing, you can say that is not a basis.
Okay.
Okay.
Okay. Yeah.
So please once explain the concept of rank, dimension, and cardinality.
Go through the last live session. Okay. Because this has been explained many times. If you have any particular doubt, I can clarify now.
Sir, actually, I attended that last session.
Still, it's not clear.
And I'm just getting confused with this.
What is your confusion?
It's not clear to me.
What is your confusion? Can you specify some confusion?
Is like, confusion is in one of the lectures, sir said that dimension and rank both are the equal.
Okay. That is your confusion, right?
Yes, sir.
Yeah. So suppose we are talking about a vector space. What is dimension? Dimension is the cardinality of its basis. Okay. And that is unique, which we have just now said. Okay. Suppose beta is a basis, then dimension is the cardinality of that basis. We also call it rank of this vector space. Okay. This is rank of vector space. But we usually prefer to use the word dimension. Okay. This is one thing. Now there is something called rank of a matrix. These two are completely different things. Okay. Rank of a matrix means you start with a matrix, you do row reduction, then you get some new matrix, reduced matrix, then the number of non-zero rows is rank of that matrix or rank of A. So this is rank of a matrix and this is completely different thing. This is the dimension of a vector space. Okay, that is the cardinality of its basis.
Okay, so what?
Is it clear? I mean, this terminology is clear, right, to everyone?
Got it.
These two are different?
Yes, sir.
Yes, sir.
Okay, great. Then, do you have any other doubt?
So please give tips for exam. Some tips.
Solve the mock paper properly. That is the only tip I can give you right now.
Practice question. Practice assignment questions are also important.
Yeah, I mean, you have already solved, I think, all the graders and practice, right?
No
So
practices.
there will be some matching type of question. A comprehension type question will be there. And pattern will be more or less same.
Okay. Question can be more
But I
than
can
the
assure
mock
you
test,
that
right?
quiz will be much easier than these assignments.
Sir, I
Really?
have seen many
Yeah.
lengthy questions in graded assignment, which is not, I think, good.
Huh?
Sir, I have seen many, I think, lengthy questions, sir, comprehensive questions. I think,
But that is for graded, so you have 1 week time. That's why there can be lengthy questions.
Mm-hmm.
But
we
in
have not
quiz,
enough
we
time to
know
read
you
this
have a
question.
time limitation. And I can assure you the question of quiz will be much easier. If you are doing some lengthy calculation, then you are doing something wrong. Okay, that I can assure you.
So I'm not talking about lengthy calculation. The lengthy question, I think, sir, 6-7 line question, which is not, I think, good.
That will not be in quiz. 6-7
Thank
line
you,
question.
sir.
Okay.
And sir, what percentage of questions are comprehensive and what percentage of questions are like numerical?
Exactly percentage I forgot. But I mean it will be equally distributed.
Okay, sir.
So comprehension will be, I think,
One comprehension type or two comprehension type questions?
so if we scale it up to 50 marks question, then out of 50, 16 marks will be from comprehension. Okay.
Mm-hmm.
Okay,
So which
sir.
week will have the most weightage of marks?
How kind of
All the
comprehensive
weeks
question?
have same type of weightage because you have to use week 1 and 2 whenever you are going to find some coefficient for linear combination, right?
Sir, we have seen
So,
like system of linear equations
Sir,
comprehensive question only in assignment paper.
uh,
So those
uh,
kind of what?
I mean, can you really segregate that? I mean, whenever you are going to find some linear combination for a spanning set, then you have to solve system of linear equation, right?
Yes.
So, how can we say this is for week 1 or week 3?
excuse me, sir.
The
Cannot
combination.
segregate like that.
Sir, I had doubt, sir.
Mm-hmm.
Sir, in Solve with us 3.1, I was had doubt in this question number 9.
Okay, 1 minute. Solve with us
3.1.
3.1.
Question number
So,
9, sir.
so difficulty of mock and quiz will be same, right?
Quiz will be easier than mock.
Okay.
Yeah. Question number 9, no?
Hmm.
This one. M2. How this text is coming here, I don't know. Okay. WA, then M2 cos M2 is a diagonal matrix. WA is a diagonal matrix, is a subset of vectors with this. Which of the following option is true? What is your doubt here?
So my doubt is if this W has to be a subspace, then zero vector should exist, right?
So
But
diagonal 0 is a diagonal matrix, right?
zero matrix is a diagonal matrix, right?
Yeah.
So okay, so but why is this in this answer is given as also subspace? For subspace, we check the three conditions, right? The zero vector should contain, and there should be vector should be closed in the addition and scalar multiplication. But in this
All these are
option,
satisfied, no?
no, first option is not satisfied. Zero
Why?
vector does not exist in W.
Why? 0 is a diagonal matrix, no?
Zero is a diagonal matrix, but in the option it's not given. I mean, the first
Option is
option.
not means this is 0 does not exist in W. This is a wrong option.
Zero vector does not exist in W. How, sir?
So
This
zero
is
is
a
a
wrong
diagonal.
option.
This should be no. I mean,
Sir, we know the
if it is
diagonal
not
matrix
a
means.
if it is not a zero vector, then W won't be a subspace.
That's what I am saying. The 0 vector exists in W.
It does not exist. Okay.
0
Okay.
vector exists in W. 0 is in
Okay.
W.
Okay.
Huh?
Okay. Zero is in W. Okay. So it is a subspace. Okay. Okay. I was very confused. Does not. I was confused. Okay.
Great.
Thank you, sir.
Sir, I have a small doubt in just a small timestamp in your lecture 4.4 for getting the dimension, sorry, with the row echelon form, I am getting dimension 3, but Sir was getting it as 2, sir.
So you are saying there is some calculation mistake there?
Yes, Sir was showing it as 2, but I am getting 3.
That may happen. That may happen. You just check your calculation properly. If you are getting that thing right, then it is
Okay. So because I am taking the non-zero rows, that is correct, right?
Yeah, exactly.
Yes. Thank you, sir.
Sir, I have a doubt in week 4 bonus activity.
What is your doubt?
Sir, I don't know why we are getting. What is the correct answer for all this?
Okay. So let me take one. Okay. Then rest I think you can do.
Sir, we are getting. I am getting 75 marks in this, but I don't know what is my mistake.
Everyone is getting the same 75.
Oh, you are getting that will be modified.
That
okay.
is some issue.
That is some issue with the programming behind it. Okay. If your all answer is correct, then that will be 100 in your dashboard later. Next week, I think we can rectify it. We have already made the changes, but we are again verifying your answers now.
So how many times we can try that test run, sir, for this one?
Due date is
well, there is a deadline, no? There was a deadline, I think.
Yes, sir. So we can check how many times we want.
Within this deadline.
Okay.
Yeah.
So just to confirm, to prove that something is a vector space, we have to prove all the 8 axioms, and to check whether it's a subspace of some vector space, we have to just prove the first 3, right?
Yeah, right. First 3, not first 3. You have to check whether 0 exists in there or not, and the closure property for addition and scalar multiplication.
Yes,
okay, thanks.
These bonus marks are not having any influence on the grading, no?
Bonus
no, that is basically when I mean it will influence your grading. Once you pass your exam, then bonus marks will give you an opportunity to get a good grade. I mean upgrade your grade maybe.
But you didn't explain anything there.
I
mean, no details were available anywhere.
No, it is already given to you, no? How the bonus marks will be given.
That's only for stat they had given, but not for math.
No, that is same for all the subjects.
All subjects.
Oh.
Yeah. I think it is already given to you.
I was under the impression it's only for stat. Okay, thank you, sir.
Yeah.
So if anybody is not asking any question, then can I ask some personal question?
Yeah, go ahead.
One
in week 5, the
week 5. Can we discuss week 5 after quiz?
After quiz.
After quiz, okay.
I'm not asking any question about that. I'm asking
okay, go ahead. Yeah.
The linear transformation concept was taught there. So, the lectures are not enough for me. Actually, I find myself. So can you suggest me any additional resource?
Lectures are not enough in which sense? I mean, the concept are not clear yet.
In week 5, the linear transformation is not clear, actually.
That's what I am saying. So concept is not clear. That's what you are saying, right?
Yes, sir.
Can you go through the solve with us once?
Solve with us assignment.
Yeah.
Okay,
just go through it. I think that will be enough.
Okay, sir. Okay, thank you.
Yeah.
So how do you check if a vector is a span? I'm sorry, if a set of vectors is a span of a certain subspace.
So you take any arbitrary element from the subspace and try to write it as a linear combination of the given set.
Okay.
That is the only procedure. Okay.
So for a single course, the time will be 2 hours, right? I mean, if those who have opted for any one course, for them the time will be 2 hours, right?
No, for each paper it should be 1 hour, no?
No, it will be 2 hours, right?
For one paper,
subject.
For one subject, it is 2 hours.
Okay.
Okay, that's what.
Hello, sir.
Yeah.
Sir, I have a doubt in solve with us week 4 question number 9. Can you please take it?
Okay. Solve with us question number 9.
2 hours, please. I think it's only 1 hour.
No, for one subject it's 2 hours.
You just take a look at the mails of the question or your admit card, okay?
Yeah, it is given in the admit card.
So question number 9. Yeah.
Yes, sir.
What is your doubt here?
Sir, I'm not able to approach it, how to solve it.
Okay. So basically you have to find a basis for this, right?
Yes,
2x
sir.
plus 3y equal to 0 and y plus 5z equal to 0. Okay, let me write it. And what was the other? Y plus 5z equal to 0. This, correct? So you have to find a basis for it. So there are two constraints on x, y, z, right?
Yes, sir.
So can we make it a single constraint? So you have given two equations like this, okay? So if we solve this, what I can tell about x, y, and z? That is the first question I need to answer. So I can write it like this, the coefficient matrix, okay?
Yes, sir.
Okay. Anyway, we don't need coefficient matrix, but first let me do this, then I will do it in another way. So I can write it 1, 3 by 2, so this is R1 by 2, 0, 1, 5, okay? Then what I can do? R1 minus 3 by 2 R2, right? So this is 0, sorry, 1, 0, minus 15 by 2, right?
Yes, sir.
0, 1, 5. So till now this is clear. So what
Yes,
I am
sir.
getting? X minus 15 by 2z equal to 0 and y plus 5z equal to 0. So I am getting x equal to 15 by 2z and y equal to minus 5z, right? So the solution, the both of these constant will eventually give me 15 by z minus 5z and z, right? Z belongs to R.
Yes, sir.
As Z is independent, right?
Z is independent, right? So here this is your pivot element. This is your pivot element. So basically x and y are dependent and z is your free variable, right? So
Yes, sir.
if we want to write the basis, what will be the cardinality of that basis? That is 1, because only free variable is z, correct?
Yes, sir.
So this is 15 by 2z, not 15 by z. Yeah. So this, if we put z equal to 1, this will be one of the bases, okay?
The cardinality is 1 because this Z is the independent variable. Right?
Independent, one independent variable. So this is one of the bases.
Okay.
One of the bases. Now, if I multiply it with 2, we will get another basis, right? This is another basis for W, correct?
Right.
Now, in the given options, you have to see what the options are. So, you know the cardinality is 1, correct? So the first one cannot be a basis because that has 2 elements. Okay? So first one cannot be a basis, second one cannot be a basis. So only possibility is for 3 and 4. And anyway we got 3 and 4 as our answer, right?
Yes.
Because we have find this as our basis, these two. Okay, there are infinitely many bases, but all should have cardinality 1. Okay?
Yes, sir.
So
Yeah,
one
no?
independent variable means cardinality of basis is 1, right?
Yeah, exactly. Exactly.
So here,
Yeah, no?
here cardinality 1, I didn't understand how we got 1, sir.
So this is your vector space, right?
Yes, sir.
W.
Yes, sir.
After solving this, I can write x and y in terms of z. So z
Yes.
is our free variable, right?
Yes, yes, sir. Yes, sir.
So if we take one element and multiply with z, that will span the whole thing, right?
Yes,
So
sir.
one vector can span the whole W.
Okay, okay, okay.
And one vector is anyway linearly independent, right?
Yeah,
So
yes,
the
sir.
cardinality of basis is 1.
Okay.
Okay. Basically, the number of free variables in this expression is your cardinality of the basis.
So in the
Right?
graded assignment, there was this question, sir, in R5, R1 and R5 were related, R2, sorry, X1 and X5 were related, X2 and X3, X4 were related, X3 was independent. So because only 3 were truly independent, the dimension was 3.
Yeah, exactly. Exactly.
But in the usual definition of cardinality, there are three. Here, anyway, we have three elements in the basis, right? So why should
Where there is 3 elements in the basis?
Here, sir.
There is 1 element in the basis.
Okay, this is a vector. Okay, fine. Got
this is a vector. This is in R3.
Okay, okay. Yeah, got it.
Okay.
Sorry, sir.
Yeah. But the set contains 1 element.
Yes, yes, I got it.
Okay. Don't get confused in that. Then everything will be destroyed for
Yes,
the vector
yes.
space. Yeah.
So for this, we first have to change it into reduced row echelon form.
Yeah. So there are 2 equations given. So we have to find a solution for these 2 equations. I mean, what we can talk about x, y, and z. Is there any relation in x, y, and z? Okay. Basically, then what I am doing the reduced row echelon form, and I am getting everything in terms of z alone. Okay. That is the solution, right? So there are 2 dependent variable and 1 independent variable. So the dependent variable can be expressed in terms of independent variables, right?
Yes, sir.
So I am writing this vector space in terms of z alone, right? So there is one free variable, that means the cardinality must be 1. And how we will get one basis of that? You put independent variable as 1 and you will get your basis. Okay? So this is one of your basis. Now if you multiply it with, so any scalar multiple will also be an element of a basis, right? So I am getting the second one also as a basis. Clear?
Yes, sir. Thank you so
Okay,
much.
great.
This should, most important, these two should be seen as vector that I missed, right, sir? These two are vectors, right? Like the 15, 2, -5, and 1.
These two are vectors in R3.
Yes, sir. Yes, sir. Got it. That I missed, sir. That's right. Thank you.
Okay. So I think most of your doubts has been answered, right?
So I have just one question from activity, question 4.2. I just like I'm understanding the question. I'm just like want to understand how the options are like given the backslash. What does this mean? Because I'm getting at times confused with this.
4.2, which one?
Third question. I'm understanding that S1 and S2 are given as the maximum linear independent and minimum spanning, so both are the bases that I'm understanding. But the options, if you could like explain me how the options are given, because this backslash is confusing me a bit.
So basically backslash means you are removing that vector.
Okay, I'm removing the v vector from
Yeah, so that is the notation, right? S minus. So that was in your maths 1 syllabus.
Yeah. It was,
S minus element. That means you are removing A from your set.
Okay. So by removing, it would remain the linear independent. Yeah, that now I can understand. Thank you so much.
Great. Yeah.
Hello, sir.
Yeah.
So just one more doubt. So activity 3.5 and question number 10.
Activity 3.5, question number 3.5. Okay. So form vector space in R3 is when it is linearly independent. Okay, so you are given 3 vectors, right?
Yes,
in
sir.
R3, and you have to find what is the value of x for which these three are linearly independent. So this is three vectors in R3. So what can you
Linearly
do about?
dependent, sir.
Huh?
It is dependent.
Linear dependent. Yeah, got it.
Yes, sir.
So what you have to do here? If I
Determinant.
write these vectors as columns of a matrix, then if I find the determinant, and these three vectors are linearly dependent, what can we tell?
Determinant will be 0.
Right?
Yes, sir.
So what is the, can you just tell me the vectors so that I can write it here? Can someone tell me the vector?
2x,
2x,
comma
4
4,
minus
comma
6.
minus 6.
Hmm.
Minus 6, minus 3x, minus 2x.
Hmm.
Minus 1, x minus 3, x plus 2.
So this is your matrix. If you calculate the determinant of it, what you will get?
0.
So I am just brutally calculating the determinant. And then something like this you will get.
It should be minus 4, I guess.
No, I have changed the sign here.
Okay.
Minus 6.
Which question? Can someone tell me?
This is the, I think, 10th question
Sir,
of
minus
activity
6
3.5.
x plus 2 instead of x plus 3 it will be x minus 3.
Sorry, x minus 3. Yeah, and it is 3x minus 3x. So anyway, whatever the equation, this is equal to 0, right? This will give, these vectors are dependent, right? So you will get an equation on x. Now solve this equation and you will get the value of x. And x is given in some interval, right? So if we get more than one values, then there should be exactly one value which is in between 2 and 5. That will be your answer.
Okay, sir.
Okay?
Yes.
Yeah. Great.
Sir, I think that there should be minus 4 only. Could you please recheck it?
No, I have adjusted it. This one, no? I have taken this first, and then this. Usually you do minus 4, determinant of minus 6, minus 1, 2x, x plus 2, right? But
Right,
what
sir.
I have done, I have taken 4 as positive and I have interchanged these rows.
Okay.
Okay? So that will
The
be
one
eventually same.
conceptual doubt I have, so in activity question 3.3, question number, just a minute, question number 6. So if you will open that.
This just now I have discussed.
Okay, so I'll watch the live stream.
You just
Okay.
please check it. Okay. I think your doubts most of have been clear. And now if you just go through all these things what we have discussed, you just see the last 2 live sessions
Sir,
and solve the mock properly. Yeah.
So here we concluded that V2 can be a linear combination of V2. Right?
V2 is always a linear combination of V2 because V2 can be written as 1 into V2. So that is a linear combination.
Okay.
Yeah.
So in the same, not in this, 7th question can you also here? 3.3. Yes, sir. I'm getting one combination as C minus C by 2 minus C and C for the answer. Why second option wrong here, sir?
In 7, how we are getting C?
I mean, after doing the row reduced form, we are getting the independent variable as Z. 1 second, sir. 1 second. Let me open this question. It's not clear at all.
So there are 3 vectors, right? 1, 0, 0. 110 and 111, right?
So this is AQ. Is it AQ 3.3, sir? The question?
Yeah, AQ 3.3, question 7, right?
Yes, sir, that's the one. But once again, I think there's a different question. Let me check once again. Sorry, sir.
Sir,
Okay, sir.
Yeah.
Sir, I tried that
Yes, sir.
same
The
linear.
option.
1 minute, 1 minute. Yeah,
Okay.
yeah, Vijay.
No, sir, I was trying that option which you suggested, sir, in the meantime on that mock quiz for option 2 of question 5, on that proper subspace for getting the linear combinations. I'm still not able to understand how the coefficients were solved even with row reduction to get that equation
That
for
is just the
getting.
solution of XYZ. I mean, there is nothing fancy going on there.
No, but I didn't get this specific coefficient, that minus A minus 2B plus 2C. I don't know how you got that, because I've been trying
First of all,
it.
the solution is unique, right?
No, I got, so any arbitrary vector of R3, XYZ, if it has to be written as a combination of three vectors, then X, Y, and Z will be given as a combination of, let us say, alpha 1, alpha 2, or alpha 3. Right? And then you are saying alpha 1 has to be solved.
Just tell me the vectors.
So the vectors are 1, minus 1, 0, 0, 1, 1, and 2, 0, 1. Now, if I have to write any XYZ as a combination of,
1 minute, 1
or
minute.
ABC as a combination.
1 minute.
Yeah.
So have you got this?
Yes.
So x plus 2z is your A, minus x plus y is your B,
correct.
Y plus z is your C, correct?
Right. Correct.
So your system of linear equation is 1, 0, 2, A, minus 1, 1, 0, B,
right.
0, 1, 1, C, right?
Right.
You have to solve this equation, this system, right?
Right.
So what you will do? So are you saying there was a mistake in calculation? That may happen.
No, I was not able to get the exact coefficients in that form.
Okay, so this is just adding, adding. So B plus A, 0, 1, 1, C. Have you checked your calculation properly?
Yes, sir. But I mean, I made it equal to. I did not put the augmented matrix in this form. I just made it equal
If
to.
you don't put augmented, then how are you getting the solution? I mean, without augmented, you will not get the solution, right?
Right. And then, if you could just.
I mean, you know how to solve the system of linear equation,
yes.
right?
Yes.
So without putting augmented, how can you solve that?
I was equating it. Okay, I took it as. I think that was.
Took it as?
I just took x, y, z is equal to this combination, and then I was trying to solve for x, y, and z. And I did not.
Then you have to put this, no? You have to equate it to some vector. I mean, I am not getting what you are saying. Have you got this system? No.
Yes, this system I got.
So if you want to solve this system, what you have to do?
Yeah.
Hey, forget this question. If you have this system of equation, if you want to solve it, what you have to do?
Right. You have to put it as augmented, as an augmented matrix. And
You have to put it like this, augmented matrix, then you have to do the Gauss elimination, right?
Correct. And then you get x plus 2z is equal to a, etc.
Yeah. Right. That is exactly what you have to do here. So this is minus, this is b plus a, so 1 minus, so b, c minus b minus a. Right? This. Now what you have to do here? 1, 0, 2, 0, 1, 2, 0, 0. I will just change the sign. A plus b minus c. Okay? Okay. Now just remove this zero, this two, 1 0 0. So a minus, I think 2a plus b minus c, 0 1 0 a plus b minus 2 into a plus b minus c, 0 0 1. This is a plus b minus c. Okay. So your x equal to a minus 2a minus 2b plus 2c. That means minus a minus 2b plus 2c. This is your x. Your y will be minus a minus b plus 2c. Your z will be a plus b minus c. Okay?
Okay.
Yeah. Got it.
Okay.
So this is nothing fancy going on here. Just solve this equation, you will get that.
Okay.
Yeah.
Thank
Yeah.
you.
So
Thank you.
who was that? 3.3 BJ?
Yes,
Yeah.
sir. Yeah, seventh question.
Ah.
Second option is coming as wrong, but I was.
That's why. Just tell me what is V1, V2, V3.
Yes, sir. 1 second, sir.
Okay, let me write it.
So V1 has given 1 0 0 0 1 0 0 1 1 1 0 1 1 1.
1 1 1, right?
Yes, sir. So we have to check for V1 plus V2, V1 plus
V1
V3,
plus V2,
V1 plus V3,
V1 plus V3,
and only V3.
only V3.
Yes, sir.
So what is the first vector?
1 0 0.
V1 plus V2. What is V1 plus V2?
Yes, sir. 2, 1 and 0.
What is V1 plus V3?
V1 plus V3 is 2, 1 and 1.
What is V3?
V3 is all ones.
So you have to check whether this is linearly independent or not, right?
Yes, yes, sir.
So just calculate the determinant.
Yes, sir. Oh, determinant. So
this is 3 vector.
I put the I took
you can do that also, no issue.
I did arbitrary ABC.
You can do that also. So let me write it then.
And I got some values for this one. C
Okay,
as
let me see.
Yes, sir.
Let me see. So this is 0 0 0, right?
Yes, sir. Yes, sir. So if you solve for ABC.
So 2a plus 2b plus c, a plus b plus c, and b plus c.
Yes, sir.
0 0 0. Okay.
So b plus c is 0.
3 equation.
Yes, sir. 3 unknowns.
This is 0, a plus b plus c is 0, and b plus c is 0, right?
0, yes.
Okay. So first of all, when b plus c is 0, if I substitute this in here, I am getting a equal to 0, right?
Yes, sir.
Okay. And b equal to minus c.
Minus c, yes, sir.
Okay. Put it in the first one. So a is 0. So 2 into 0 plus 2b. b means minus c plus
minus
c equal to 0.
Plus c, 0.
That means minus c equal to 0. That means c equal to 0. If c is 0, then b, what will be the value of b? This is also 0.
But
so all the terms are 0, right?
Yes, sir. But if we, let's say we are not directly going to a, b plus c is 0, so b is minus c. So a, okay, a will be 0. Okay, a will be 0 from the second equation.
Obviously, this has to be unique. No
okay. So it will be independent, not dependent, right? Okay. Maybe I made a mistake in calculation.
Yeah.
Okay, thank you, sir. Thank you. Thanks, sir.
Yeah. Great.
Hello, sir.
Okay. Yeah.
Sir, is orthogonal matrix in our syllabus?
It is in our syllabus, but in week 8, not 8. Week 7. 7. Yeah.
Okay, sir.
I mean, when we are introducing inner product space, then it will come. Okay. 7 or 8, it will be there. Okay. So yeah, all the best for your exam. I think it will go well.
Sir, just 1 minute.
Thank you, sir.
Yeah.
Sir, in the 3.36 question, I only have doubt in one option. If you can just tell me, like, the why, if V2 is a linear combination, if V1 is a linear combination of V2, V3, and V4, then why is V2 not a linear combination of V1, V3, and V4?
So, see, this is the example I have given. So this is V1, V2, V3, V4. Okay.
Yes, sir.
So is V1 linear combination of V2, V3, V4?
Yes, sir.
I can write it like this, right? So this
Yes,
is
sir.
your A, this is B, this is C. Correct?
Yes, sir.
Now is V2 is the linear combination of V1, V3,
No,
V4?
sir. No, sir.
So have you got your answer?
Yes, sir. Thank you so much.
Great. Basically, if this A becomes 0, then the problem arises. Okay. Otherwise, you can take it on one side and divide with A. But if A is 0, then you cannot do it. Right?
Yes.
Yeah. Great.
Thank
Okay.
you. Thank you, sir.
Thanks you.
Yeah.
Thanks, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you
Thank you,
very much.
sir.
Yeah.
Thank you,
All the
sir.
best for exam. Yeah.
Thank you.
Thank you, sir.